All right, today we are going to go over basic postulates and theorems.
Is this a paper for the K level?
That's not my class. Mine is online. Yeah.
It's online? Oh,
yep.
Okay.
So, good thing you reminded me. Thank you. Your K level letters are due. It's online. Only about 10 of you in this class have done it. So, you need to go into Schoology, find the little link that says K level letter at the bottom, and I need you to do that today with your parents. I'm going to send out a reminder because a lot of people have forgotten. Okay? All right. Today we're going to talk about the basic postulates and theorems of geometry. A postulate, if you can write this down, a postulate is a given fact. For instance, the sky is blue. That is a fact. How do I prove it?
Look up.
You look up. That's going to be the same thing for some of these. Hey, this creates a line. Why? Look at it. Okay? So, that is a postulate. A theorem is something you can prove. It is a conjecture, a statement. I spelled that way wrong. A conjecture you can prove. A conjecture you can prove. Okay? So that's the difference between a postulate and a theorem. One is given to you, the other you can prove it. So, for problem number 1, what I would like you to do is I would like you to draw a straight line through this point right here. You can use your badge if you don't think you can do a straight line without. But draw a straight line through this point. That is your instruction. You have 5, 4, 3, 2. Draw a straight line through that point. 2, 1. Does everybody have a straight line drawn? Okay, I want you to talk to your neighbor. Look at your lines. Did you and your neighbor draw the same line? Don't erase if you didn't. It's okay. Did you and your neighbors all draw the same line? All right, look up. Did you draw the same line as me? No. Why not? Hey, because I didn't give any other instructions, did I? I just said draw a line. Did anybody draw a horizontal line like this? A couple of us? Okay. Did anybody draw a line vertical, straight up and down? That's been the most popular today. What about a line going down, a negative line? Did anybody draw that? A couple people? Okay. How many more lines could I draw through this point? Lines are straight. Has to be straight. Yeah, no, it's okay. So, but couldn't I sit here kind of all day and just to see how many lines I can draw? And what do you think I'm going to end up doing? There are infinitely many lines I could draw through this one point. Now, do I have time to do that? Nor is my pen skinny enough? No. But do you agree I could? Yes. If you only have one point, there are infinitely many lines. Now what I would like you to do is I would like you, using your badge, to draw a line through both of these points. I want one line that goes through both of them. 5, 4, 5. Now I want you to look at your neighbors and see, did you draw the same line? Alright, now look at me, please. Look at my board, Look at my board. Did you draw the same line as me?
No.
How is your line different?
I drew it from the one on the left to the
Okay, but I said through these 2 points.
I didn't let
We're going to have a following direction exercise. All right. Does everybody's line look the same through these 2 points? Why? There's no other way you could go. Could you have done this?
No.
Why not? That's not straight. Lines are straight. Look up at my board. Is there any other way to draw a line that goes through both of these points?
No.
No. Why?
Because it's no other solution. So because one line they're going in the direction, that means that it can't be going in another direction.
Exactly.
All lines have to be straight, so it can't be like
It can't go back, right? Any 2 points, there is, I want you to write this down, exactly 1 line. That is your first postulate. Through any 2 points, there is exactly 1 line. And when I ask you why, because that's a fact, right? I just proved it to you, but not super easy without going through all those steps, right? That's a fact. Any 2 points, there's exactly 1 line. What about if I have 2 lines that intersect? What does intersect mean? They cross. If you have 2 lines that intersect, where do these lines intersect at? At R. And what is R? A point. So 2 lines intersect in exactly 1 point. Are they ever going to intersect again? No. Why not? Because once they go off, are they ever going to meet again? No. Shut your Chromebook, Marcella. You don't need it. Okay? So when you have 2 lines intersecting, they intersect at a point. What is an example of that in like the real world? Like streets. Hold on real quick. Streets. Do you agree roads are like lines? Right? If they're straight. And do you agree whenever you have an intersection, that's like one big point? Okay? Especially on a map. What is another example of 2 lines intersecting at 1 point? An X. The letter X. Don't you agree the letter X is 2 lines? Intersects in the middle. Look at my hover cam. Sorry, people online. Do y'all agree these are 2 lines? And what does the people that designed this hover cam, they put on the middle where they intersect? They literally put a point. Alright? So, 2 lines intersect at a point. Look up. The ceiling. Aren't there just a ton of intersecting lines? And don't they intersect at a point? Okay. Next. What about 2 planes intersecting? Why do they intersect at exactly 1 line? Y'all answered the question before I asked it. Good job. I want you to look at this paper. Unfold it. Do you agree because I folded it, I now have 2 different planes?
Yeah.
And where are they intersecting at?
The 1 line.
The crease. And this crease happens to be what shape? A line. Alright? I want you to think about your Chromebooks or any book. What's in the middle of your Chromebook or of any book? The spine. The line. Alright? Look up at the walls. Find a wall. Find another wall touching it. And I know this room's weird because it has those little columns in the middle, right? But when you have in your room, when you have 2 walls intersecting, touching, what do you have? A line. So, if 2 planes intersect, they intersect at 1 line. Look at these 2 planes. I have RST and STW. Where do these planes intersect? ST or... No. TS. You can either write ST or TS. I'm a Taylor Swift fan, so that's why I wrote TS, but ST is right. Either one of them are right. There you go. As in like X-Men?
No, as in like the soccer.
Oh, dang. As in like the position?
Yep.
You're a soccer player?
Huh? No. I'm a mindset player.
Let me ask Coach Gonzalez. Or Gonzalez. What? Gonzalez. The JV coach?
I don't play soccer. I just have interest in ball.
Alright. Next. I want y'all to please look. Let me actually just... Do you agree that I have 3... Let's pretend the points are these things right here. Okay? Y'all agree I have those? Okay. If I wanted to make a plane, I'm going to take our other worksheet that we're going to do. Do you agree if I laid this plane flat right here, it would create a plane? And I'm touching all 3 points. Right? What about if I took this and put it straight up? Do you agree I'm still touching all 3 points and it's a different plane?
Yes.
What if I tilt it sideways like this? Am I still touching all 3 points and it's a plane? If I have 3 points in a line, how many planes can I create that touch all 3 points? A lot. How many is a lot? Infinite. Infinity. There are infinitely many planes if you have 3 points in a line. Now, yes.
Are the planes like the space in between lines?
No. Flat surface. Flat surface.
So is it?
So this is a flat. This is a plane. It's flat. So how many flat? Like if I could hold these up, if I could have y'all hold these up and put them in a line, I would do like this. You see how it touches it? That's a plane. Pretend it's flat. That's a plane.
Isn't there is there other planes on that paper?
No, this is just one plane, right? So do you agree that touches all 3 points?
Yeah.
But if I turn it like this, do you agree it's still touching all 3 points?
Yes.
So it's another plane. And then if I turn it this way, it's another plane. So I can turn this kind of circular and get infinitely many planes that way. Now, y'all look up at me, please. Look up at me. What happens if they're not in a line? Do you agree I now kind of have like a triangle? Okay. If I touch them like this, is it touching all 3 points?
No.
What if I have it like this? Is it touching all 3 points? No. What am I going to have to do? Now is it touching all 3 points?
Yes.
Pretend it's flat. I know it's not because my hands. How many planes can I make? Or how many times can I make a plane and it touch all 3 points like this? If I turn it like that, is it touching all 3? No. So how many ways can I turn it so that it's touching all 3? Once. What's the difference between this right here and this right here? Okay, so boys in the front, pay attention. I know y'all are probably talking about this, but focus. If you have any 3 points that are all in the same line, like we had in the beginning, that makes a bunch of different planes. But if they're not in the same line, it makes exactly one plane. What do we call it when it's not in the same line? We learned this on Friday. Non-collinear. If you have 3 non-collinear points, they make exactly one plane. We call this unique. So if you see the word a unique plane, unique means there's only one. That means you have 3 non-collinear points. Okay? How many points do you need to make a line? 2. A unique line. One line. You need how many points to make one line? 2. Because remember over here, when we only had 1 point, how many lines did we have? But when we have 2 points, how many? 1 line. How many points do we need to make a plane? 3 points to make a plane. Think of a tripod. Could you hold up a camera or anything if you just had 2 legs? No. Would your desk hold up if there were just 2 legs? No. Would your desk hold up if there were just 3 legs? So actually it'll hold up, but as soon as you put pressure on it, it'll fall over. Bella, are you with me? Alright, so any 3 points make a plane. Think of a dog. Is there such thing as 3-legged dogs?
Yeah.
Can they still walk?
Yeah.
Yeah. What if it was a 2-legged dog? Most of them need like a little wheel behind them to make the 3rd point, right? So, 3 points makes a plane, 2 points makes a line. Alright, now this next one, shh, boys. This next one's going to be like, okay, miss, we're just going to write it down and it is what it is. 2 points. Do you agree S and T are on that plane? If I have 2 points on a plane, If I connect them, where is that line? It's also on the plane. And you're like, duh. I'm just saying it so you know. It's not going to be like in another dimension or anything. Okay? That one's, I don't have much to tell you besides that. A line and a point not on that line. Can you underline the word not? So I have a line right here and I have a point. How come they make one plane? Because how many points are there right here? 3. Write that down. Any 3 points make a plane. What makes a unique plane? One non-collinear. Let's use that word instead. But you're right. I get what you're saying. But non-collinear. If they were all on the same line, they'd still make a plane. They'd actually make a bunch of planes. And that should say points, not point. Any 3 points. And these are non-collinear. Are we okay? I know this is a lot of information. This is not on your quiz tomorrow, I don't think. Quiz tomorrow. I've only said that 4 times already. Alright. Look up at me. I need everybody, or I guess you can look at the board. Look at the board. I have a paper. Y'all see that? Yes. I have a pencil. Do you agree a paper is a plane? Yes. Do you agree a pencil's like a line? Yes. What happens when I stab this paper with this pencil? Yes. It's intersecting. Do y'all see how that is intersecting? Yes. What is it intersecting at? At a point. You'll see how I made a hole in the paper? That's a point. So, when a plane and a line intersect, if it's not on the plane, it intersects at a point. Think of a pencil stabbing a paper. Y'all with me still? Yes. 2 lines intersect. Then they lie on the same plane. Why? No matter what. Doesn't matter if one goes like this, one goes like this, one goes like this, one goes like... They're on the same plane. Why? How many points do they make up? 3. Do y'all agree they make up a point where they cross? Do you agree because it's a line it has to have at least another point? And this one also has to have at least another point? How many points is that? 3 points. So 2 intersecting lines are contained in exactly one plane because they have 3 points that are non-collinear. And hey, guess what? Number 9 says that exact same thing. A plane contains how many?
3.
At least 3. So could it contain 4?
Yes.
Yeah, because at least. Think of your desk. How many legs does your desk have? 4. And isn't that a flat surface? So you can have more than 3. But primarily at least 3. You need 3 for it to work. Okay? And then last but not least, if you have 4 points and they are non-coplanar, meaning 3 of them are in one plane and another one is not, then you have space. That's how we have the space around us. Okay, we get out of here at 5. So I have 15 minutes. 05. I'm sorry, 05. I have 15 minutes. All right. We are done with these notes. I want you to keep them open but put them to the side. Because now some of you have got it and some of you have already been mind blown, but I'm going to blow your mind a little bit more. Assuming and not assuming. Okay? The number 1 rule in this class, and I'm probably going to tell you, hey, you broke the number 1 rule. The number 1 rule in this class is you do not assume. Do not assume. Because when you assume, it makes a out of you and me. You can figure that out. Or not. When you assume, it makes the beginning of the word out of you and me. Thank you. I'm not saying that on camera. Now, these things right here are things you can't assume. I don't even like that. You're not assuming. These are things you know. You're not assuming them. We know. Do you agree we know lines are straight?
Yes.
Yeah. Do you agree that if I give you these collinear points, that this one is between those two on the outside? Yes. We know that. It's not like it's not between it. I can see it's between it. Okay? We also know, do you agree, we know those points are on the same line. They're collinear. Okay? These are things we know. We also know that if I see two lines intersecting, they are intersecting. It's not like they're in different dimensions. One's right here, and it just looks like it. If it looks like they're intersecting, they're intersecting. Okay? We know that. Yeah. We also know that interior to exterior. This point right here is inside the triangle. Do y'all agree with that? Yeah. We know that. That's about all we know. Yeah. So, what I'm about to tell you is going to kind of take away everything you learned, not everything, but a lot of things you learned in middle school, even elementary school, to believe. You cannot believe those anymore. For instance, if I draw you this picture, is this segment smaller than this segment? Yeah. We don't know. But Miss Olivares, it looks smaller. If I don't put numbers there, you don't know. Because guess what I'm going to do on Wednesday? I'm going to say that's 10 and that's 3.
So if you spread out.
I don't know what this, just pictures are not drawn to scale in this class. So what ends up happening is I'll take a picture and then I'm going to copy it on every single problem. Am I going to write the same numbers on every problem? No. And so what happens is I don't want you to start assuming, hey, just because that side's bigger, that doesn't mean anything. The same way, if I give you this, what type of angle is that?
We don't know.
We don't know. This could be 100 degrees. Is 100 degrees acute?
No.
No. But if I tell you it's 100 degrees?
Yes, it is 100.
No.
It's 100 degrees. That's not acute.
Yeah. Right.
So, can't assume anything just by looking at a picture. Next thing you cannot assume. Midpoint. We learned this word on Friday. Is that the middle of this line?
No.
We don't know. Does it look like it is?
Yeah.
Yeah, I drew a pretty good picture just then, but we don't know if it is.
Different numbers.
This could be 5 and this could be 6. When will I know? When I give you numbers, or if I give you tick marks. If I give you tick marks, then you know. Tick marks, these mean that both sides are the same.
Little lines?
Little lines, I call them tick marks. So if you get little lines, they're the same. Then you can say it's midpoint. But if I don't give you any lines, you don't know. What about this? How many degrees is this angle? What do you want to say it is?
I want to say something.
You want to say it's a 90-degree angle. Is it a 90-degree angle?
No.
It's 91. It could be 89. It could be 100. We don't know. What do I need there to know? Either a square, or I could actually put 90 degrees right there. Can y'all please write these down with me? If I'm writing them down, I want you to write them down. It's okay if you haven't yet. I got you. On Friday, we talked about parallel lines. What does that mean? Do these lines never touch? I don't know. I have no idea. We can't assume parallel lines. I taught you on Friday. I did it very briefly. What did I tell you on Friday? We would know. How do we know if lines are parallel? Does anybody remember?
If they're going in the same direction but different sides.
But how do we know that?
No. The parallels.
It has to have an extra set of arrows. If it has an extra set of arrows, that's me telling you, hey, these are parallel. If there are no arrows, we don't know. Is that Ricardo over there? Where's Ricardo? Are you Ricardo? Okay. Making sure. That's Ricardo, Armando. Who's next to Armando? Malachi? You with me? Okay. All right, next. Special figures. This made a lot of people mad last period. What shape is this?
That's a square.
We don't know.
That's definitely a square.
How do you know all the sides are the same? You don't. You don't.
How do you know all the angles are the same?
You don't. No, you can't assume. Can't assume. I have to tell you it's a square, or I would have to tell you all the sides are the same. You don't know the sides are the same. You don't know any measurements. It is going to mess you up a little bit. We're going to practice it. So, let's do that real quick. Let's do all of practice 1 together. Are we okay? We frustrated? A little bit. It's okay. Okay. What does this symbol right here mean? If you didn't know that, can y'all write it down? That symbol means perpendicular. Are lines K and lines P perpendicular? What does perpendicular mean? 90 degrees. Are lines K and lines P perpendicular?
Yes.
We can't assume it, but how do we know? There's a square. What if there wasn't a square? Then we wouldn't know. But they were nice. They gave us a square. We know. A, B, and E form a unique plane. So I don't know why they didn't put dots there, so I'm going to add them. A, B, and E. Do these form a unique plane? Yes or no?
We don't know. We don't know because the lines don't connect.
We don't know.
Okay, but how many points form a plane?
3.
3 what?
Dots.
3
lines.
non-collinear. Are these 3 non-collinear points? They do. So anytime you see this word unique plane, you need non-collinear points. If it's unique, non-collinear. Are K and R parallel?
Yes. No. We don't know.
Wait a minute. They look like it, don't they?
We don't have to.
But did they give us anything to tell us they were?
No.
So no, we do not know. They could be, but I don't know. They look like it, but we don't know. Is D, let me put a dot on D so we're not confused. Here's D. Is D between B and C on that line?
Yes.
We don't know.
Yes.
So now you're questioning everything, right? Like you're like, obviously it is, but obviously that was a square earlier, so now I don't know anything. Look at the top. Where is the word between at the top of our paper? Is it we know or we not assume?
We do know.
We can assume betweenness, so that's yeah. Now you're questioning everything, right? Does BGA form a unique plane? BGA, why not? They're collinear. I want non-collinear. A unique plane needs to be non-collinear. Those were all in the same line. So it does form it forms a lot of planes, right? What does this symbol mean? Congruent. What does congruent mean? So write that down if you didn't know what that symbol meant. Congruent. Is BD the same as BDC? So here's BD. Here's DC. There's no line. Are there any numbers? So then I don't know anything about it if there are no numbers. We cannot assume. Excuse me. We cannot assume that. I need my water. Y'all, is F inside the triangle? Are you sure? Yes, it is. That is the location. We can assume if it's inside or not inside. So we know that. Last but not least, is G the midpoint? Is G right here the midpoint of AB? Yes, only because why? If there were no tick marks, it would be a no. So I'm going to give you 1 minute. I want you to do the next ones, 1 through 5, on your own. And if it helps you, you can draw dots on X, Y, and Z right here. Yes.
Are we even done?
Yeah, you only have 3 minutes left in class. Yeah. Do these 5 and then I'm going to give you the answers. Be careful. All right. I know y'all might not be done, but I want to get this before the bell rings. Is line A parallel to line B?
No.
Are these parallel?
No.
Why not? We don't know. There's no symbols. Hold on. Don't pack up yet. Is anything perpendicular in this?
No.
Why not? No box. Are X and Z collinear? Are they on the same line? Yeah, we know that. Is XY, be careful because y'all see the tick marks, y'all want to say true, but make sure you're paying attention. Congruent to YZ.
No.
Are there tick marks on those? No. And then is Y on line A and C? Yes. All right. Your homework tonight, we're going to do our things. Your homework tonight's in Schoology, but that's not due till Thursday. Make sure you get 1 and 2 turned in tomorrow. I don't want you to start off with a 0. Worksheet 1 and worksheet 2 due tomorrow.